We are being recorded. All right. So somebody needs to ask a question so I can answer it. Maybe you guys logged on and then you're not at your computer right now, but let's go. It's 7:30. One. Andrew, are you there? Type to me. All right, I'm going to start with something from the quiz that a lot of people seem to struggle with. It's number 3 from the quiz. Okay, now some people are typing. Good. All right, so I'm going to do quiz number 3. I actually had a group say, I don't think we ever learned this, which is kind of funny. It has been a while, I will give them that. But yeah, we have learned this. All right, as a matter of fact, tomorrow I'm probably going to have you guys take out your notes from this section and show me, or I'm going to show you what you wrote down. And it was that I told you when we did these that something just like this was going to be on the test. I call these the formula problems. It's where they give you a formula and ask you to solve for one of the variables. And my hint was that one of these would be on the test, but one of them that has the variable that you're solving for in 2 different places, and that's the case here. So they asked you to solve for p, and I'm circling my variable that they asked me to solve for, like I've suggested that you do, and it's on both sides. Okay, so I need to get those together, so I'm going to leave this p here, and then I'm going to add that whole term, PRT, to both sides, so then that equals a. I'm still going to go back and circle my p's. So I notice I have 2 terms on the left side of this equal sign, and they both have something in common, p. We always look for something in common first. And so when I factor that out, I'm left with 1 plus RT is equal to A. And since that's P times the quantity, doesn't that mean they're factors? And so I can divide through by that quantity, 1 plus RT on both sides, and factors can be canceled. And so there's my P. All alone, it equals A over 1 plus RT. And that's it. All right, so that's the one I wanted to do for you. Andrew, I was just trying to get you to ask a question. Okay, let's see. Luke, thank you for asking. So number 15 and 17B from the quiz. All right. All right, 15, quiz number 15. Let me write it out. It says to the quantity x minus 1 equals, so this is an equation, 13 minus 4 over x minus 1. So I'm sure you can hear me saying in class, oh, it's an equation with a fraction in it. So what's the first thing we should do? Get rid of the denominators. So I'm going to multiply by x minus 1 specifically to get rid of this denominator, but every single term has to get multiplied by x minus 1. And I wanted to double check to make sure that I copied that right. And I did. Okay, so I said every single term has to get multiplied by that x minus 1. So on the left side of the equal sign, this is just one term. This whole thing is one term. Now it does have 2 factors, but it's only one term. Then 13 is another term. And then, of course, this fraction is the third term. And that's the whole point of why I'm multiplying by x minus 1. But every single term has to get multiplied by that. Okay, so I think I'm going to leave my 2 alone for now. And I'm going to multiply the x minus 1 times x minus 1, because you only multiply once since it's only one term. So that is, in essence, squaring x minus 1. And so I know my pattern. I square the x, I multiply the negative 1 and the x and double it, so I get negative 2x, and then I square the negative 1, and that's positive 1. Okay, then I'm going to get equals, and now it's 13 times the quantity x minus 1, so that gives me 13x minus 13. And then for my third term, this x minus 1 in the denominator cancels with that. That's the whole point. So I just get minus 4. Okay, so now I have a quadratic equation, but there are no more factors. I'm distributing my 2 first. And then this side, I'll go ahead and simplify. The negative 13 minus 4 is negative 17. And now let's bring everything over to the left-hand side. So I've got my 2x squared. I'm going to subtract 13x. That gives me minus 17x. And then I'm going to add 17, and I get plus 19 equals 0. Now, if any of you are decent factorers, and what I mean by that is you can factor something like this by trial and error, you probably thought that this was factorable. I did. And so I started trying to factor it, and then I realized, wait a second, the signs are off, and it's not factorable. And that can be confirmed by doing b squared minus 4ac. And if I don't get a positive perfect square, then I know it's not factorable. So let me just do that real fast. 17 squared minus 4 times 2 times 19 gives me 137. That is positive, but it's not a perfect square. So I'm going to solve this by using the quadratic formula. So the opposite of b is 17 plus or minus the square root of. I'm not even going to do that again or write it all out again. I just did it in my calculator to test to see if this was factorable or not. Remember, I got 137 for my discriminant, and then all over 2a is 4. So it ends up being pretty easy once you realize that it's not factorable. Okay? All right, there's number 15. All right, I'm getting ready to do Luke's second question, but you guys, why aren't you asking questions? Okay, number 17b. So while I'm doing this problem, will you please ask questions that you have, either from the quiz or from your review from yesterday or from the extra credit review that you've been working on? I know you've got to have questions. Okay, so Luke, I have 2x minus 3 all over x plus 1, and then that is greater than or equal to 0. Okay, so the two things I notice as I first look at this problem is my fraction is already being compared to 0. That's exactly what you want for these types of problems. This is considered a non-linear inequality, so that's where we're going to do the number line with all the signs. And I also notice that I don't even need to factor anything. Okay, this numerator, you don't have to put the parentheses, but I feel like when parentheses are around a quantity like that, you guys realize, oh yeah, those are factors because they're being divided, and factors are either multiplied or divided. Okay, so I'm going to set each factor equal to 0 to find my two critical values. So if you set 2x minus 3 equal to 0, and let me talk myself through this a little bit, I'm going to add 3 and divide by 2. So there's one of my critical values. Then I'm going to take x plus 1, set it equal to 0, and solve for x, and I get negative 1 for my second critical value. So on my number line, I'm just going to put negative 1 and positive 3/2. And now I'm going to do the signs. Okay, so to the left of negative 1, I think I'm going to pick negative 10. And so I plug in negative 10 into my numerator, and I get a negative. And then in my denominator, I plug in negative 10, and I also get a negative. So a negative divided by a negative is positive. All right, between negative 1 and positive 3/2, I'm going to plug in 0. And so I get a negative in the numerator, a positive in the denominator, and that quotient is negative. I'm circling my result, my quotient. Okay, and then I'm going to pick positive 10 to the right of positive 3/2. And when I do so, I get a positive in the numerator and a positive in the denominator. And so that quotient is positive. So looking at my signs, I have a positive, a negative, a positive. That's exactly what I was expecting, is alternating signs. If they are not alternating, you better go back and figure out, did you get the wrong critical values? Did you plug in a number incorrectly? Go find your mistake, because there is a mistake. Okay, right here where I'm putting this red arrow, greater than 0 means positive. So I'm going to shade in the positive regions. Okay, I'm going to put an arrow here because it goes on forever, and an arrow here. I know there was already an arrow on my number line, but that's not shaded in. So I want you to shade in to show me you know that this goes on forever. Okay, and then I need to make a decision about my two critical values. So because of the equal sign, I suspect some people are going to put closed circles on both of these. However, the -1 came from the denominator, and we never want to divide by 0. Ever, ever. That's considered undefined. So on -1, I need an open circle, but then on +3/2, I get a closed circle. So the closed circle is because of the equal sign. I do want my fraction to equal 0. And so with a numerator equaling 0, that makes the whole fraction equal 0. But I never want to divide by 0. And so the -1 that came from the denominator has to be an open circle. All right, here is my answer in interval notation. Parentheses, -infinity, comma, -1, and then right parenthesis, union. Now I'm going to have a bracket, +3/2, comma, infinity, and parenthesis. Okay, there you go. Yay! Thank you, Jennifer, Gianna, and Hannah for speaking up. All right, Jennifer, can I go over number 12 on the quiz? Yes, I can. Okay. Quiz number 12. So they gave us x to the 4th plus 10x squared plus 25 equals 0. Okay, so these are a few of the things that I thought as I was grading your quizzes. Apparently, you guys don't realize that because this is an x to the 4th equation, a 4th degree or quartic polynomial, I don't think you guys realize that you have to have 4 answers. So this is the type of problem where we said, and you don't have to use this letter, but I usually use t, let t equal, and then I'm going to look at my middle variable right here, and that's what t is going to equal, is x squared. So now I'm going to rewrite this quartic polynomial in terms of t. So it would be t squared plus 10t plus 25 equals 0. Okay, so I recognize that that's a perfect square trinomial, so I know that's going to factor into the square of a binomial, so I get t plus 5, the quantity squared, or if you factored it out, whether you used an x or you saw how it factored and you wrote t plus 5 times t plus 5, that's fine, all of those are equivalent to what I just wrote. Do you realize, though, that you get t equals -5, and it is a double root because you have 2 of those factors? Okay, so you have to keep that in mind. That's a double root. And now I'm going to take this t equals -5 and go over here where I wrote let t equal x squared, and I'm going to plug in my -5 into that equation and set it equal to x squared. Okay, so here's where I got a little angry at you guys. I am taking the square root of both sides of a quadratic equation. Do you agree that x squared means this is quadratic? I don't know how many times I said this to you guys. I'm going to switch to purple because I like purple and I want this to stand out. Don't forget the plus or minus. It's a quadratic equation, you guys. You have to get 2 answers, not just the square root of -5, but plus or minus the square root of -5. So I get x equals plus or minus. Now my square root of 5, I can't simplify, but then the square root of -1, that's I. Okay, so for this x, I get 2 answers, plus or minus the square root of 5 times I. That's my x. But remember, that was from plugging in one of these -5s for t, but I have 2 of them. Well, when I plug in the second one, of course, I'm going to get the exact same answer, another plus or minus the square root of 5 times I. So here's how I'm going to write my answer. Double root. And so if there are 2 positive square root of 5 times I, and then 2 negative square root of 5 times I, that is a total of 4 answers. And that makes sense because it was a 4th degree polynomial. Okay, there you go. So that whole plus or minus thing, I'll tell you right now what's on your quiz. An arrow, I wrote plus or minus, I put an arrow, and I put a big sad face. I am very sad / mad that so many of you forgot the plus or minus. It's crazy. I don't know what to do to make you guys remember the plus or minus. Okay, Gianna, page 101, number 22, and this is from the extra credit review. All right, page 101. And number 22. Okay, so this is similar to one of the ones that I did from your quiz. Write down page 101, number 22. Here's the similarity. I see that I have an equation with fractions, and so I hope you're saying to yourself, oh, then get rid of the denominators. If you guys are getting a common denominator, you are making life so much more difficult on yourself. Please just remember my suggestion. Oh, it's an equation with fractions. Get rid of the denominators. All right, I'm going to put r on both sides of my equal sign. Okay, so this r I'm going to distribute to the first term on the left side of the equal sign. And then on this right side, I'm going to put that I need to distribute it to the 4 as well as to this fraction. Every single term has to get multiplied by r. Okay, so I'm going to switch to red. And do you see that in the on the left side of the equal sign? Don't you dare distribute the r to the 3r plus 5. The whole point of this is to make that denominator cancel. So you need to start forcing yourself to look for that. When you have a fraction, look to see, does the denominator cancel with something, so that you can simplify and make your answers, your numbers smaller, or in this case, they cancel completely, and that was the whole point. Okay, so I suspect this 4 is the one that maybe you forgot to distribute the r to. That's very common. It's not okay. It's just very common. That's why I did my little arrows or arcs going across, so I wouldn't forget that. And then for this last term, look at this. The r cancels with the r, so here I just get plus 5. Okay, I'm going to subtract 3r from both sides, so I get r on the right side of the equal sign. I'm going to subtract 5 from both sides, and I get 0. Okay, now the answer r equals 0 does not mean the empty set. Okay, I just want to be clear that the number 0 is just like getting a number 2 or a number -3. I got an answer for r. However, this is one of the two situations that you can have extraneous roots in, and that's when you have an equation with fractions and there are variables in your denominator. So doesn't my original equation have restrictions because of this r in the denominator and this r in the denominator? That means r cannot equal 0. Otherwise, my denominators would be 0, and that's considered undefined. Well, that happens to be the exact answer we got. So I'm going to reject this, and that's what makes my answer the empty set. And those of you who are in my class, I want you to tell me you got r equals 0, but you rejected it. That's why your answer is the empty set. Okay? All right. Gianna, I hope that was helpful. Okay, Hannah, page 144, number 25. Okay, and that's perfect timing because that brings us to the second type of situation that can produce extraneous roots. Doesn't mean it will, but it can. All right, page 144, number 25. All right, this equation says the square root of x plus 8, and then outside of the square root minus 1 equals 2x. Hold on just a second. I'm going to turn on my fan. Okay, so whenever you have a square root or any kind of radical in an equation, we said that our first step was to isolate the radical. So I want to get it all alone on one side of the equal sign. And so to get this -1 to the other side, I'm going to add 1. All right, the next step is I want to get rid of the square root, so I'm going to square this side, and then here's where you guys need to be very clear on this. When I go to the right side of my equal sign, you cannot square each term. That doesn't work. You have to square the entire side, and that's a binomial, so I'm going to square this binomial. Okay, there's no discussion about this. It is wrong to square the terms. Okay, it's a heck of a lot easier, but it will only result in a wrong answer, so don't do it. Okay, so when I square on the left side, when I square my square root, those undo each other, and so I get x plus 8 equals, and then here I'm going to use my pattern that we've discussed in class. To square a binomial, you just square the first term, so that's 4x squared. The middle term is the one that usually students mess up on. What you want to do is multiply this 2x times this positive 1, so I get positive 2x, and then double it, so I get plus 4x. And then to get my third term, I just square the positive 1, and that's positive 1. Okay, so I have a quadratic equation. I want my equation to equal 0, so I'm going to leave my 4x squared on this right side. I'm going to subtract x from both sides, so I get plus 3x, and then I'm going to subtract 8, so I get negative 7. Okay, if this is factorable, then I would like to factor it. I'm going to double check to see if it is or not. So b squared is 9 minus 4 times negative 7, and I get positive 121. So that means this is factorable. Okay, so let's see. I'm going to try 4x and x, and if you guys need to make an x to do this, go ahead and do so. 7 is prime, so I know it has to be 7 and 1. And so I'm going to make this positive and this negative, and let's double check to see if I just factored correctly. So my 4x times x is 4x squared. That's good. I get negative 4x for my outers plus 7x for my inners. That adds up to plus 3x, so that's good. And then positive 7 times negative 1 is minus 7. So we're good to go. And so I get x equals negative 7/4 and positive 1. Okay, so I'm very happy with my two answers, but I have no idea if they are both final answers until I go back, switch to red. I must go back to my original equation, plug it in right here, because I had to square both sides in that second line, and that is considered an irreducible step that could result in extraneous roots. Okay, so let's start with the 1. If I plug in a 1 here for x, I get the principal square root of 9, which is 3. So 3 minus 1, and I want to know, does that equal 2 times 1? Yes, it does. So this 1 is good to go. All right, let's see. I don't know that I love doing this with a calculator, but I'm going to take my negative 7/4, which is negative 1.75. I'm going to add 8 to that, and then I'm going to go square root of answer, and I get 2.5. Okay, so let me write 2.5 right here, and then minus 1, of course, that equals 1.5. So now on the right side of my equal sign, I'm going to go 2 times negative 7/4, and I get negative. Oh, I'm sorry, hold on. Yeah, I forgot to put my negative in. Okay, time out. Let me start over again. My negative 7/4. Oh, no. Plus 8 is positive 6.25 when I take the square root of answer. I do get 2.5. Okay, I thought I made a mistake there for a sec. Minus 1, so this left side of my equal sign equals 1.5. On the right side, I'm doing 2 times negative 7/4, and of course I'm going to get a negative. So 2 times negative 7/4, and I get negative 3.5. Well, those are clearly not equal, and so this is an extraneous root and needs to be rejected. Okay, for people in my class, here's how I want you to write it. Here's your answer column line. I want you to tell me that your answer is x equals 1. Tell me the answer first. Then tell me that you got x equals negative 7/4, but you rejected it. Okay, that's how I want you to show me on the test. Okay, all right. Who was that? Hannah. I hope that was helpful. All right, Alyssa, can I go over number 3 on the quiz, please? I think I already did. I did that first thing when nobody was asking any questions. Yep, it's already at the beginning of this, so go back and rewatch that. Okay, Tate, can we go over number 31 on page 101? Yes. Keep those questions coming, you guys. Okay, 31, actually, it's on the next page, 102. Okay. All right, page 102, number 31. All right, so we have 3 fractions in this equation. So 3 over p plus 4 plus 4 over p plus 3 equals 4 over p squared plus 7p plus 12. Okay, so as soon as I see that I have an equation with fractions, first thing you should do is get rid of your denominators. All right, I'm going to go ahead and factor this third fraction, the denominator of the third fraction. I know I've got a p here and a p here, and I'm going to have plus 4 and plus 3. And so instead of this quadratic trinomial, now I have those two factors. All right, so in order to get rid of all of these fractions, you do not want to get a common denominator on both sides. Eventually, you have to get rid of the denominators anyway. So please just trust me. The first thing you should do is get rid of your denominators. Okay, I'm going to multiply by p plus 4 and also by p plus 3. I'm kind of squeezing that in because I knew I was going to run out of room. All right, so both of those factors need to get distributed to this term, also to this term, and then of course to this term. Okay, on the left side of the equal sign, for the first fraction, my p plus 4's cancel, and I end up with 3, the quantity p plus 3. I'm just writing it out since it's so far away, and then I'll come back and distribute in a moment. Okay, then I have my plus sign. Now when I distribute the p plus 4 times p plus 3 to the second fraction, the p plus 3's cancel, and so I get plus 4, the quantity, p plus 4. And then to the right side of my equal sign, when I distribute those two factors to this, both factors in the denominator cancel with both factors that I'm multiplying by, and I just get 4. That's actually the easy side. Okay, so now let's solve this pretty easy equation. I'm going to distribute my 3 carefully. And you know what, I feel like I need to say this. Many of you should be doing this and this before you go to distribute. So many of you make mistakes with the distributive property. I don't know why, but you do. And so if you know that's you, that's ever happened to you on a test, start doing those little arcs like I just showed in red to force you to remember, oh, that's right, I have to do 3 times 3, and I have to do that 4 times 4. So many of you are writing 4p plus 4, and that's wrong, obviously. Okay, my p's add up to 7p. On the left side, that adds up to 25, and when I subtract 25, then I get negative 21. Divide by 7, and I get negative 3 for my p. All right, because I had variables in the denominator of my fractions, that means I have restrictions. Let me write those restrictions up here in green and label them as restrictions. Now, they didn't ask you to state what the restrictions are, okay, but you're supposed to go back and plug these in to make sure that they work. Well, I just want to talk about the restrictions because that's going to tell me what my extraneous roots are. P cannot equal negative 4 or negative 3 because that would make my denominators equal to 0, and that's considered undefined. And so since I got negative 3 for one of my answers, I'm going to reject it. And if this was on the test, my final answer is the empty set. I'm just going to put that symbol there. And then I'm going to write that p equals negative 3 was an answer I got, but I rejected it. Okay, notice I did not write p does not equal negative 4 or negative 3. I'm not asking you to tell me what the restrictions are. I'm telling you I want you to write down what you got for your answer, which was negative 3, but that you rejected it. Okay? All right. Let's see. That was 31. Tate's question. All right. I hope that helped you. Okay. I think I'm down to the last question, Andrews. So come on, the rest of you. Ask some questions. We have 15 people here. You guys have got to have questions. Okay, Andrew's question is on page 128. And number 19. All right, let's see. They are asking us to solve this by completing the square. All right, I'm going to write it the same way they did. 2x squared minus 8x equals negative 16. All right, so I happen to notice that there's a 2 in common with every single term. And even if there wasn't, I have a leading coefficient of 2. And so even if all 3 of these were not factors of 2, multiples of 2 rather, I would still divide through by 2 like this. All right, so I get x squared minus 4x, and then they were actually kind of being nice to put that negative 16 on the right side. I get negative 8 over here, and notice I just left some room in between my negative 4x and my equal sign. I'm going to write plus blank, and on the right side, I'm also going to write plus blank. All right, so because I now have a leading coefficient of 1, I take this middle coefficient of negative 4, you take half of it, or divide by 2, and then you square it. So doesn't that give me plus 4? And I have to do that on both sides, of course, because this is algebra. You are balancing it out and doing it on both sides. All right, the whole reason this is called completing the square is because we just created a perfect square trinomial. So that, of course, factors into the square of a binomial. And you take the square root of x squared, you take the square root of 4, and you take the sine of the middle term. Okay, you all should know how to factor that. And then when I add those two numbers together, I get negative 4. All right, I'm getting ready to take the square root of both sides of a quadratic equation. So let's get some pretty purple. Don't forget the plus or minus. I'm solving a quadratic equation. I have to get 2 answers. All right, so the square and the square root cancel. I get x minus 2. On this right side of my equation, I have my plus or minus, and then the square root of negative 4 is 2i. So then I want x all alone. I'm going to add 2 to both sides, and then I write my plus or minus 2i, making sure that any complex answers are given in a plus bi form, and these are. So there are your 2 answers. Okay, Andrew, I hope that was helpful. All right, Tate is asking for number 37 on page 102. Number 37. Okay, great question. This is the section, by the way. Oh, section 2.1. Yeah, it's been about, what, 2 or 3 weeks since we did section 2.1. So I suppose it shouldn't surprise me that you guys have forgotten about it. That's why your review assignment was so important. All right, page 102, and you asked for number 37. So these are the problems I call the formula problems. So they gave us a formula that's A equals H over 2, the quantity A plus B, and they're asking us to solve for little b. All right, so I suggest on these problems, there's so many variables going on, circle the variable you're trying to solve for. It will kind of make your brain focus on that and say, okay, I'm trying to get that little b, lowercase b, all alone. Okay, so first I would like to get rid of this h over 2, and I can do that in one step. Let me do this in red, by multiplying by its reciprocal. So 2 over h, do you agree that'll make my 2's cancel? It'll make my h's cancel. Ta-da, it's all gone. All right, I'm going to write on the left-hand side 2 over h as well, like this. All right, I think some of you struggle on how to multiply a fraction times a non-fraction. So I have 2 over h, that's my fraction, and then I have this a, and I think you guys don't know what to do. So here's my suggestion. Just write the a as a over 1, and then it should be very obvious that your numerator is 2a and your denominator is h. That's what you get. All right, on the right side of my equal sign, all those h's and 2's canceled, so I just have a plus b left. And I'm going to go back and circle my b again. So if I want that b all alone, don't I just need to subtract a from both sides? And there's my b. Now, I'm perfectly happy with this answer. There's nothing wrong with this. However, when you looked in the back of the book, you went, that's not what they got. I know, because they got one fraction, and you can too very easily. If you look at the back of the book and recognize that they just have one term, whereas you had 2 terms in this boxed answer, if you did it the way I just showed, that you just need to get a common denominator and see what your answer would be as one fraction. So watch what I'm going to do with that a, because I think that bothers you. Just write it as a over 1. Okay, so now my common denominator is h. First fraction, I already had h as my denominator, so my numerator stays as 2 times capital A. And then, excuse me, my second fraction, my denominator is a 1, was a 1, and now it's an h. So I have to multiply the numerator also times h. And so that, I believe, is the answer that they had in the back of the book. Those are exactly equivalent, and it doesn't matter which way you write it. Both of those are acceptable. Okay. That was tape question. Yeah. Okay, so Elaine, page 101, either 41 or 43. Okay, let me see which one I like better. They're both good. Let's do both of them. Okay, so page 102, number 41 I'll start with. Okay, both of these are those formula problems. Okay, so it says lowercase p equals capital S divided by S plus F, and they are asking me to solve for S. So I'm going to circle that. So let me reiterate again. I warned you guys in class when we did this way, way, way back when we were working on section 2.1 that these formula problems absolutely would be on the test, and you could count on the fact that you're going to get one where the variable they ask you to solve for, in this case S, is going to be written twice, and that's exactly what we have here. Okay, excuse me. I see that I have an equation with a fraction in it, so first step should be get rid of the denominator. So I'm going to multiply both sides by S plus F. Notice I write my S plus F on this right side nice and high, as if it's a numerator, because it is. Okay, and the whole point was to cancel that denominator. So on the right side, I just have an S, now that those have canceled. On the left side of my equal sign, I'm going to go ahead and distribute. Okay, we usually write our variables in alphabetical order, so I'm going to write PS plus FP. Okay, and I think if you're not circling the variable you're trying to solve for, you're going to get so lost in this problem because there's variables all over the place. Okay, so I'm circling my S's. I still have two terms that have an S in it. I need those to be on the same side. Since this S is already here, I'm going to subtract PS, and then on the left side, I already have my FP, and that's going to stay there. Okay, let's switch to red and circle our S's again. Many of you will get to this point and then get stuck. Here's where you need to talk to yourself about factoring. You always look for a common factor first. Isn't S in common with both of those terms? And I'm trying to solve for S, so I need to factor it out. When I do so, I'm left with 1 minus P, and over here I still have FP. Since I am solving for S and want to get it all alone on one side of the equal sign, aren't I ready to divide by this factor? Because factors do reduce, even though terms don't. But that's why I factored that S out to make it a factor. And so here's my final answer. I'll write it in red. S equals capital F times P all over 1 minus P. And that's my final answer. Okay? All right. So moving on to the next question. Okay, let me write Elaine's second question. Page 10, actually it's 102. Number 43. All right, I was just reading Antonio's question. So Antonio, when they say solve by factoring, his question is, would completing the square work as well? It will give you an answer. However, if they ask you on the test to factor, we want to see that you know how to do that technique. And so no, you need to factor. Now, if you want to complete the square, get the answers, and then go back and say, well, okay, now that helped me factor, go ahead. I mean, that's a lot of work, but go ahead. But no, when they ask you to factor, you need to factor. When they ask you to complete the square, you need to complete the square. And then, of course, the third choice is if they ask you to use the quadratic formula, then you use the quadratic formula. There are 3 ways of solving quadratics. You can't always use all 3 of those ways, but those are the 3 ways. Okay, let me do 43 now. So we have S equals little a minus r times capital L all over 1. I'm going to write my 1 like this so it doesn't look like an L minus r. And they are asking me to solve for r. Oh, there's an r here and an r here. Hey, this would be fair game on the test. You've been warned. There will be a problem that has these formula type things with the variable you're solving for in 2 different places. All right. I hope this is starting to click and stick with your brains. When you have an equation with fractions in it, first step should be get rid of the denominators. Okay, so I'm going to multiply every term on both sides by 1 minus r. Switch back to black. Okay, let's do the right side of the equal sign first. Doesn't this cancel with that? That was the whole point. So I get a minus RL, just the numerator now on the right side. On this left side, I'm going to distribute the s. See what I just did? I showed the little arcs like that. So I distribute to the 1, and then I'm going to write minus lowercase r, capital S. Okay, and I'm going to go back and circle my little r's. So I have 2 terms on the left side of the equal sign, 2 terms on the right side of the equal sign, and these 2 terms that I'm underlining both have the r in them. So I need to decide which side I'm going to go on with my r's. I want to get those on the same side, and then everything else I want on the other side. So let's go to the right. Okay, so I'm going to add little rs. Okay, so I added it from the left side. Now it's on the right side. And then I'm going to keep my minus RL. Let me just circle those R's again so you can see. Oh yeah, she brought the 2 terms that have the R's in them over to the right-hand side. So that means I want the other 2 terms to be on the left-hand side. Well, I already have the S there, and now I'm going to subtract that lowercase a. Okay, on this right-hand side, this is oftentimes where you guys get stuck. You've got your r's on the same side of the equal sign. That's good, but I need to get r all alone. Isn't it in common with the 2 terms? So let's factor it out. So r, the quantity, s minus l. Now those are factors, and that equals s minus a. I'm able to divide both sides by s minus l, so those factors cancel. And so over here, I also need to divide by s minus l. So my r is now all alone, and it equals s minus a all over s minus l. Now, I'm not sure what they have in the back of the book, but if by chance they have a minus s in the numerator, then their denominator would be l minus s. That's just the opposite of the numerator and the opposite of the denominator, and that happens if instead of having the r's go to the right side, if you made them go to the left side. Okay, but totally equivalent answers. Okay, there you go, Elaine. All right, Antonio, I already answered that question. And then page 151, number 21. Okay, and as of right now, that's the last question that's been asked. So we still have 15 minutes left, so please ask some more questions. All right, 151. All right, this is from section 2.7 and number 21. Okay. All right, so this says 3w squared plus 13w minus 10 is greater than 0. Okay, these are considered non-linear polynomials, or excuse me, non-linear inequalities. And whenever you have a nonlinear inequality, I want you to say to yourself, oh, these are the problems where you have to do the number line with the plus or minus signs. Okay, so just to give you a visual, something like this, where you're going that's positive, and that's negative, and positive, positive, or whatever, okay? That's what I'm talking about, the number line with the signs above it. Okay, but first, I must have my inequality being compared to 0. It is. That's good. And then I have to have factors on the left-hand side. Okay, so I'm going to put 3W here, W there. Let's see. I'm going to go 2, yep, 5 and 2, and I want the 15 to be positive and that negative. Okay, so if you need to do an X to factor this, you do what you have to do. All right, I'm going to double check my trial and error here. My 3W times W is 3W squared. My outers give me plus 15W. My inners give me minus 2W, so that combines to give me positive 13W, and then finally minus 10. Okay, so I take this first factor, 3W minus 2, and set it equal to 0 and solve for W. I get positive 2/3. So that's one of my critical values. I take W plus 5 and I set it equal to 0, and I get W equals negative 5. I don't know that anybody's thinking this. Nobody's ever asked it, but you might be thinking to yourself, why are you setting it equal to 0 when there is no equal sign on the inequality? You always do that to get your critical values, because I need to make my number line with the critical values that are going to separate my number line into 3 parts. So I put negative 5 to the left, positive 2/3 to the right, and now I'm ready to do my signs. Okay, to the left of negative 5, you can pick any number. You can pick negative 6. That makes me nervous, though, because I bet you somebody's thinking, oh, should we pick negative 4? No, that would not be to the left of negative 5. So I personally think you should pick negative 100. Just be very obvious that you are to the left of negative 5. Okay, in this, let me box this in red. In this completely factored form right here that I'm boxing in red, that's where you're plugging in your negative 100. So negative 100 plugged in for W in the first factor is going to give me a negative, and I'm going to write that in that area of my number line. When I plug in negative 100 in the second factor, I get another negative. And so a negative times a negative is positive. I'm going to write that in red and circle it so it stands out. Okay, so that whole region is positive. Then in between negative 5 and positive 2/3, I can pick anything, but 0 is really easy to plug in. When I plug in 0, my first factor is negative. When I plug in 0 to the second factor, that one's positive. And a negative times a positive is negative. I write that in red and circle it. Okay, to the right of 2/3 is an infinite number of numbers. I'm going to pick positive 100. When I plug that into the first factor, it's positive. Second factor, also positive. And of course, a positive times a positive is positive. Okay, now I look right here, let me circle this in green, at this inequality. I want my product of my two numbers to be greater than 0. Well, translated, that means positive. I want the product to be positive. All right, so I look back at my graph, my number line. This left region is positive, so I'm going to shade there. This very right region to the right of 2/3, that's positive. I'm going to shade there. I'm going to put shaded arrows to indicate that I know this is going on forever in both directions. And now I need to make a decision about my critical values. Now there are no fractions going on here, so we don't have to worry about dividing by 0 or being undefined. But when I look at my inequality, it just said greater than 0, not greater than or equal to 0. So that means I want open circles on my two critical values. Okay, and here is my final answer in interval notation. Negative infinity to negative 5, parentheses around both of those, union 2/3, 2/3, comma, positive infinity, and parentheses around both of those also. Okay, there's your final answer. All right, we're at 8:20, and I just did Antonio's question. Okay, Jennifer, number 9 on the quiz. right. Okay, they asked you to solve by completing the square. So 2x squared plus 8x plus 10 equals 0. All right, since they're asking us to complete the square, the first thing I would do is divide by 2. And every single term, including that 0, needs to get multiplied, or excuse me, divided by 2. All right, so I get x squared plus 4x. I'll go ahead and write my plus 5 equals 0. But because we are completing the square, next I'm going to write my first two terms and write plus blank equals, I'm going to bring that 5 over to the other side so it becomes negative 5, and then I'm going to write plus blank again. Okay, since my leading coefficient is now 1, I go to the middle coefficient, this 4, I take half of it and square it. So half of that is 2, square it, I get 4, and I have to add the same thing to the other side. This left side is a perfect square trinomial, so that always factors into the square of a binomial. I get x plus 2, the quantity squared, and that is the square root of the x squared, the square root of the 4, and then the sign of the middle term. And on this right side, I get negative 1 when I combine those. As soon as I say that I'm taking the square root of both sides of a quadratic, I want you to say to yourself, but don't forget plus or minus. The beautiful purple plus or minus. Okay, so left side of the equal sign, square root and the square cancel, I get x plus 2. Right side of the equal sign, I still have my plus or minus, and then the square root of negative 1 is defined as being I. So here's my last step. I want x all alone, so I'm going to subtract 2, and then I have plus or minus I. And those are my two solutions to the equation, and they are complex conjugates. Okay, there you go, Jennifer. Okay, Tate, I think you have the distinction of being possibly our last question. All right, number 13 on page 120. Number 13 on page 120. Okay, this problem actually won't take that long. If somebody has one last question, we will have time still. It's 8:23. Okay, so somebody else please ask one more question. All right, this is page 120, and we are doing number 13. Okay, so it says, making sure I'm doing the right one, yes. Okay, it says 17 plus 5, the quantity, x plus 2, is less than or equal to x minus 3, the quantity, x minus 2. Okay, Tate, I'm not sure if I know your mistake, but I have a guess. All right, so this is just an inequality that I'm trying to solve. There are no fractions, and so I'm just going to solve this. All right, so the first thing I see on the left-hand side is that I want to distribute that 5 to those two terms right there in the parentheses. So 17 I leave alone, then I distribute my 5, I get plus 5x plus 10 is less than or equal to. Okay, here's where I have a guess. Since that x plus 2 is in parentheses on the right side of the inequality, I have a feeling maybe some people considered the x minus 3 as if they were parentheses. You know what, I'm going to put it in red, and then I'll delete them, okay? If you did this and distributed and, got an x squared minus 5x plus 6, that is wrong. There were no parentheses around that x minus 3. So this means x, I'm going to write it in red, and then I distribute the negative 3 here and get minus 3x plus 6. Does that make sense? And again, I don't know that that's where you made the mistake, but I could see that being a problem for some people. Okay, on the left side, I guess I'll just combine these. So I get 5x plus 27 is less than or equal to negative 2x plus 6. So let's go ahead and add 2x to both sides. That gives me 7x is less than or equal to. I'm going to subtract 27 from both sides, and I get negative 21. Okay, my next step is to divide by positive 7. So you do not change the sign, and you get x is less than or equal to negative 3. Now, this set of directions said, determine the solution sets for the following inequalities. Okay, they didn't say to graph, but I'm going to suggest that we should graph because then it makes it so easy to write my interval notation. So I'm just going to put negative 3. Since that does have an equal sign, I'm going to put a closed circle, and then x is less than that, so shaded to the left. And so when I go to write my interval notation, I'm going to go left parenthesis, negative infinity, comma, negative 3, bracket. And there's my answer. Okay, you don't have to graph that if they didn't ask you to, but I just think it makes writing interval notation so easy. Okay, let's see. What did I just do? I did 13. Okay, so we have 2 questions. Sarah, I'll have to look to see if I've done that, and I'm not sure that I'm going to have time to. Okay, page 144, Hannah's question number 9. Page 144, number 9. Okay, so this is an equation with fractions in it. So of course, we're going to get rid of the denominators. Number 9. Okay, it is 6 over y plus 2, the quantity squared, plus 1 over y plus 2, and that equals 1. Okay, so I want you guys to start kind of talking to yourself and recognizing this is an equation with fractions. Get rid of your denominators first. So I'm going to multiply by y plus 2, the quantity squared, because I want to get rid of both of my denominators. Y plus 2, the quantity squared. Okay, I think I'm going to go like this, and like this, and like this, so I don't forget to distribute to every single term. All right, the y plus 2, the quantity squares, are going to cancel completely, so that first term just turns into a nice, easy little 6. All right, plus, when I distribute to the second fraction, one of the y plus 2's cancel, but then my plus 1 in the numerator needs to get multiplied by the other y plus 2. So I just get plus y plus 2. And then on the right side, this is the tricky part, you have to multiply the 1 times y plus 2, the quantity squared. So let's do our pattern. You square the first term, that's y squared. You multiply the 2 terms together, that's positive 2y, but then double it, so plus 4y. And finally, you square the second term and get plus 4 for my third term of my trinomial. All right, since that is a quadratic equation, I want one side to equal 0, so let's make the left side 0. I already have the y squared on the right side. Now when I subtract 1y, I get plus 3y. Might not be a bad idea to kind of cross out as you go. I've taken care of that and that and that. And so I still have these 2 guys that add up to 8. And this guy over here. So when I subtract 8, I get minus 4. Okay, let's see if we can factor this. Y here, y there. I'm going to go 4 and 1. I want the 4 to be positive, the 1 to be negative, and let's double check. Y times y is y squared. I get minus y plus 4y. That gives me my plus 3y, so that's good, and then minus 4. And I get y equals negative 4 and positive 1. Now when I go back and look at my original equation, I did have a restriction on y. Y could not equal negative 2. However, I didn't get negative 2. Okay, so that means there are no extraneous roots. Now, should I go back and plug in negative 4 and positive 1? Absolutely. I have a teacher's edition here, so let me just go to the back real fast. I'm going to try to save a little bit of time and just make sure that we're correct. Okay, you should plug in, because on the test, obviously, you're not going to be able to double check. This is page 144, number 9. And negative 4 and positive 1 are both correct. Okay, all right, but you should double check. The whole extraneous root thing here, though, is that if I had gotten negative 2, that would have been an extraneous root because of the whole dividing by 0 thing. Okay, Sarah, let me look at 101. If I have done it, then we're done. If I haven't, I will do it quickly. 101, number 44. Nope, I haven't done that. Okay. All right. Let's see. Page 102, number 44. Okay, this is my last question. All right. So it says little m equals C, the quantity 100 minus P, all over 100 minus D, and they're asking me to solve for little d. Okay, I see an equation with fractions in it, so let's get rid of our denominators. So I'm going to multiply both sides by 100 minus D. On this side, that's going to cancel. That's the whole point. On this side, I need to multiply by 100 minus D as well. So I'm going to show my little arrows like that so I don't forget. Okay, go back to black. So I get 100m minus little d times m equals, I think I'm going to distribute my c here. So I get 100c minus cp. Okay, we're solving for d, so I'm going to go back and circle that. It's only in one place, so this is a little different than our other problems. You know what? I think I'm going to add dm. Watch what I'm doing here, so that I get a positive coefficient, because right now the coefficient of d is negative m. Okay, because of that negative sign, I think it would be wise to add it so that it's on the right side, and then let's just bring everything else over to the left side. So the 100m was already there. I'm going to subtract 100c, and then I'm going to add cp. And let's circle our d again. And so all I have to do is divide by m, and I'm done. So that all over m, this all over m. So my m's cancel, of course, and so d equals 100m minus 100c plus cp all over m. And that's your answer. Okay, there you go. All right, guys.